Thank you, everyone, for still being here this late in the day. This is our last session of the day. We're closing a bit early in the other tracks. So now I'd very much like to welcome to the stage Chris, who's said to just interrupt him if he carries on too long. Because his presentation could easily go for 3 or 4 days, did you say?
Yeah, 3 or 4 days, something like that.
Okay, well, welcome, Chris, please.
All right, thanks for still being here. I had these visions of talking to an empty room because it was right at the end, but thank you. My name is Chris. Wiley, people generally call me Wiley because there's a lot of Chris's in the world. It's more of a unique identifier. My background is mostly in network engineering and security. This talk isn't really going to have much to do with Python like the last talk, but unlike the last talk, I ask that you please stay anyway. Most of my experience has been in higher education, so generally lots of connected devices, lots of bandwidth, lots of public IP addresses. So I'm going to be coming from that direction with this talk. That may or may not reflect your world, but that's kind of my bias. I'm going to be talking about IoT, because it's the IoT stream, and it kind of seems like the thing to do. And when I'm talking about IoT, I'm talking about unattended computers, right? So this is any kind of computing device where people don't really pay attention to it. And so that could be your traditional ballet slippers or light sensors or vending machines or what have you, but also home routers or printers or things that you don't really pay attention to the computer inside of. It's really the unattendedness of the computer that makes it an IoT thing in my world. All right, quick security briefing. So in security, we often talk about CIA, and if you don't know what that is, we talk about confidentiality, which is around unauthorized disclosure of information. We talk about integrity, which is unauthorized modification of data, and we talk about availability, which is people trying to take data away. And when I talk about DOS, really, I'm talking about anything that affects the availability of information or services. Okay, definition's done. Sorry, can move on. All right, so DDoS. Traditionally, we affect DDoS in one of 3 ways. If we start at the top of the stack, we've got application attacks. And so these are when you code an application and someone does something that isn't what you expected, and the application crashes, right? And so if you have an example like this, right, you as a human can look at that and go, that's stupid. There's no answer, it's a logical paradox. But a computer would sit there and spin through it over and over, chew up all its resources, and then fall over in a giant heap. These are some of the oldest types, like people here heard of ping of death. It was an old Windows 95 thing. So this was actually an application attack against the network stack of Windows 95 machines. You got a big packet and broke it up into chunks and you send it to it, and when it reassembled it, it crashed the stack and the box fell over, right? So you have one packet crash the box. So when you're writing your scripts, pay a lot of attention to error handling or you're going to run into this kind of stuff. All right. Sorry, deep breath. The second type is state exhaustion. And I kind of picture this like a telephone switchboard exchange, right? Your computer has a bunch of sockets for connections into and out of it. And there's 2 sort of ways to attack this. The first is that you try and overload the handler, so the person who's actually trying to plug sockets in, because there's only so many sockets they can connect at one point in time. If you can flood that person with new connections, they can't introduce new ones, and people can't get access to things. You also have a finite limit on the maximum number of connections, and you can fill that up as well. So this kind of comes in with, I think Slow Loris is probably a good example of this, which is a HTTP-based attack where you talk really slowly to a web server. And sorry, I got sick of the game partway through. And you have a lot of people doing that, and the web server actually fills up because there's people talking to it legitimately, just very, very slowly. And you can max the amount of responses or the amount of simultaneous connections it can handle. And the last one is a good old volumetric attack, which is just you have more bandwidth than them and you flood them and they go away. And like in the good old days, if you had like Optus cable and your friend had a dial-up connection, you could just make him go away if he was beating you in a video game, right? You just throw ping packets at him and he went off the internet. Not that anyone here would have done that, I'm sure. But when people started using this to try and attack larger corporations, they didn't have bandwidth superiority, right? This only works if you have more bandwidth. And they tackled this in one of two ways. So the first way is amplification. So this primarily uses UDP connections. And what I've got here is an example of me just querying Google's domain name servers for IBM's information, which is the top one. So that's me sending 64 bytes of packets. And you can see that they've sent 779 bytes of return traffic. So that gives me an amplification factor of about 11 to 1. UDP doesn't actually require any connection, so you can actually set your target's address as the source address for your packet. And when you send a packet to the DNS servers, they send the packet to your victim. This kind of blew up in a big way earlier this year with Memcache. Anyone heard of Memcache? And that had about 50,000 times amplification. And the other way is with bots. And that's kind of where we're going with this, right? In 2016, Mirai ran around. I don't know if people have heard of Mirai. So it was most famous because it attacked Dyn. If you care about Krebs, it attacked Krebs as well, but most people care about Dyn. And when it disrupted Dyn, it disrupted small companies like Amazon and Visa and CNN and things that no one's really heard of, but people did care about it, right? It used 68 sets of default credentials, and it primarily targeted home routers, IP cameras, DVRs, that's the other big one. Logged into them, installed some malware, and then used them to flood Dyn with GRE traffic to the tune of about 1.2 terabits. And this is almost all from home IoT devices. So I kind of see that there's a problem with this, right? So when you're at home plugging these devices in, there is large real-world consequences for the way that you approach some of that stuff. So traditionally, what do people do about IoT? If you're a company, you put in load balancers, maybe you go to Cloudflare, which is just a big fancy load balancer with content distribution, or you get some Arbor or A10 boxes or Radware or something and do some scrubbing, or you just buy more bandwidth and hope that that solves the problem. That's the traditional tertiary education, where you just get more bandwidth, right? Okay, order. But what we've started to see more of is not just companies trying to defend from DDoS, but companies getting hurt from inside by DDoS. I'll give you a quick, short story. There's not much on the slide. Don't worry, you're not missing anything. So this happened earlier this year. A company was setting up a branch office. They were running a bit behind schedule, so things were a bit tight for them. People were tired. They were working late. The network engineer's like, all right, I got all the network kit installed finally. Sweet, I'll take off for the weekend. The AV guy's like, all right, I've got everything cabled up together. Sweet, I'll take off for the weekend. I'll come back and configure it when I get in on Monday. Over the weekend, the mail guys realized that they can't send mail to external. All their external bound mail is bouncing. And digging into it, what they find was that the network guy had a default VLAN configured on the switch with public IP addresses. And the AV guy had just cabled it up. All the devices had picked up public addresses from DHCP. They'd been owned, and people were using them to send out spam. And this very quickly led to the company's mail server being blacklisted from the internet. This is pretty common. It was pretty simple to fix. The people didn't change any of the passwords or anything like that, right? And you might be sitting there thinking, hey, wait, I don't really think that that's a denial of service attack. But from a security perspective, when I look at the impact that this had on the business, the inability to send mail is the primary business impact. I mean, you could talk about reputation in this case, right? But I'm guessing that no one in this room knows who I'm talking about, so I would argue that reputation is not a major factor, right? It was the loss of the ability to send mail for a couple of days while it waited for this company to fall off the blacklist. All right. So what do we do? Change passwords, right? And this is going to be a primary theme throughout this, and I'll expand on this a little bit more later, but whenever you're plugging any IoT device that you're doing, whether that's your Arduino, Raspberry Pi, whatever, right, into a network, Arduino-driven Raspberry Pi, whatever, into a network, change the password before you log it into the network. And the second thing is about being aware of when things are actually exposed to the internet. Because often people are like, it's fine, but there's a lot of people out there who are just waiting for devices to crop up to log into them and use them as spam cannons to defraud people on behalf of your company. So in that previous example, it was actually job offers that were going out. That was part of an advanced fee scheme. So those kind of things can be damaging, right? And you don't want your company to end up blacklisted because people are broken. And you don't want your home to wind up with these compromised devices either. So how do we do this? All right. Simple, quick answer I've got is a site called Shodan. How many people here actually know what Shodan is? We've got a couple of people. So Shodan is effectively a big web catalog of internet accessible devices. It tells you what ports they're accessible on. So if you go back to that big state table switchboard, it tells you what ports are listening on the internet. And it also has lists of webcams and cameras with admin. Admin is the login and password and all sorts of other exciting things. One of the really cool things about it is that it does have API keys. So if you create an account, you can get API keys. And then you find Python people can write scripts to go and for your organization or your home or some organization that you want to know the information of for unknown reasons, download lists of all of their publicly accessible devices and kind of track that over time. One of the advantages of doing it this way is you don't actually have to do any of the scanning, you don't have to do any of the intrusion, you're just consuming a publicly available information source. It's kind of neat and easy. All right. I'm going to do a little bit of a longer story now. So this is actually a US university that this happened to. They had gone smart campus happy, so they had vending machines and light posts and light bulbs and everything that they possibly could connected to a network because they thought that it was the best, right? They could do all the user tracking that we saw 2 talks ago with lights and thermal images, but they could actually watch people going around with cameras and all sorts of things. So one night, the help desk starts getting calls that the network is slow. And if you've ever been an ops person, you know that in networking, you know the network is always slow, and it's almost never the network. But they're getting calls about this. And they do some digging, and they find that DNS is sluggish. So they kick it off to the DNS engineers, and they have a look at the logs, and they can see visually that there's a lot of seafood-related domains in there. And if you ever run DNS servers that have like 40 or 50,000 people, the DNS logs are a giant mess of everything. Like you can't see anything in them, but they could visually see seafood-related domains being looked up. It's kind of weird. Kick it over to the security team. Definitely not normal operations, right? Security team have an external company that they pay when they need it for digital forensics. They figure that this is sufficiently fishy to qualify, so they so they kick it out to the digital forensics company with firewall logs and all of that kind of stuff. And the picture that they get is that they've got about 5,000 devices on their campus that have been compromised and are looking up a couple of thousand different domains that all resolve to about 5 different addresses, and then they're hitting those addresses. And you can probably guess where we're going with this, that the 5,000 addresses is their IoT network. Operationally, if you've ever run something like DNS, you are never resourcing it for what could happen. You're kind of looking at the baseline and looking at what might happen and sort of modeling it along that. Your DNS servers are almost certainly not resourced for an additional 5,000 devices making queries, even if it's relatively small, right? So just these devices being owned led to DNS effectively being DOSed from inside. So they go and look at the devices. They find out that the passwords have been changed to these ones, which is pretty cool. They've got kits on them, and at this point, their management's kind of shitting itself, right? Because they're like, We've got 5,000-ish devices. They're embedded in things. We probably don't have access to half of them because they're built in walls and all sorts of places, and we've lost access. Luckily, a coder bails them out. So a coder realizes that the command and control infrastructure, so when you've got a bot, it calls out to someone else to get instructions. That channel was in clear text. So with a bunch of packet dumping and a bunch of data analysis, they were actually able to get passwords to the devices, and they wrote some scripts to sweep through, log into all the devices and change their passwords and regain control of them all. Happy ending, right? I guess except for the couple of days where everything was screwed. But in the end, happy ending. So I'm going to talk to you about a couple of other things that you can play with. But first we're going to talk about permissions. I don't know if this is, it's close enough. When you start doing intrusive testing in things, you run the risk of falling afoul of the Cyber Crimes Act, and there's potentially prison terms associated with it. So really, really make sure that you know what you're doing before you go trying to log into stuff. So if this is in your workplace, make sure you have written permission before you're doing this. The scale of this stuff is more for workplaces, but your home may have sufficient quantities of IoT in it to qualify. I don't know, I'm not you, right? But if it's in your home, feel free to go nuts. So after Mirai dropped, Rapid7, who's the company that does Metasploit, they released a piece of Perl code called IoT Seeker. And that has a bunch of web login extensions. And you fill it up with a config file with a bunch of default credentials. It has some package, and it will actually run around through your IP list trying to log in and telling you when things are audited. It's relatively simple. It's relatively easy. The source code is all up on GitHub. You can go nuts with it. But the tool that I would really like you to go away from playing with from this, other than having a look at Showdown, which you seriously should because it's awesome, is a tool called NMAP. Hands up if you've ever used NMAP for anything. Put your hand down if it was for something other than port scanning, or fuck, I don't know, I screwed that one. Anyone ever used it for anything other than port scanning? 2 people? All right. So generally it's a port scanner, right? So going back to the sockets again, this is the same sort of thing. Like Showdown is effectively a big catalog of this and some other stuff. You pick a host, you port scan it, you find out what's open. And so from this, you can see that we've got H323 is listening, which is a video encoding port. We've got SIP, which is voice. And so we can probably reasonably assume that it's some kind of video conferencing server, right? Because I don't know if you guys know anything else that uses voice and video encoding. And we can see that you've got NetBIOS, which means it's probably a Windows box. I don't know why it's running SMTP, but it is, although luckily it's dropping it so people can't talk to it on it. There's a web server and some other stuff. NMAP's really good for discovering the devices on your network that may be vulnerable. But the NMAP scripting engine is where you actually can start doing cool stuff. A lot of this stuff is online. While NMAP itself is open source, I really wouldn't recommend going and mucking around with changing NMAP itself. But the NMAP scripting engine is all written in everyone's obviously favorite language because you're here, which is Lua. This is the same language that you write your World of Warcraft add-ons, so if you have a lot of experience with that, take that, Mum, who said that wasn't a transferable skill. But so not to scare you, but the Lua actually functions in a very similar way to Python in this context. Obviously, you've got some semantic difference in the way it's structured, but you've got your libraries that you import, and a lot of those are shared classes, and then you've got the scripts themselves that call it. And you'll find examples of SSH and HTTP or HTTPS or Telnet or FTP brute forcing. So you build big password lists, and you run around and you try and brute force your way into all of the devices. Like I said, this is pretty intrusive, right? So the permissioning part is actually pretty important here. But if you're in an organization and you're a developer and you can get permission, I would highly recommend actually having a look into doing a bunch of this stuff. And I ran through my slides really quickly, even though I said I wouldn't. So that's like the end of the thing. I don't know how much time that is. But I guess we can answer, I guess we can just ask questions.
Yes, thank you very much, Chris. We are about, I think about 10 minutes finished early. So we can take out some questions. Anyone got any?
Thank you for the talk. So one of the things, problems with IoT devices, that beyond the default password, which you can relatively easily change,
Yep.
A couple of other vulnerabilities that might require an update to the firmware. And remember, you're asking people to do this who might not necessarily be all that technical, and so it's quite a challenge to actually secure an IoT device. And this is an ongoing problem, right? So
Yep.
what would you say would help with that?
So, I mean, from an organizational perspective, a catalog of devices is going to help, right? One of the reasons that I focus on this kind of stuff in the talk is when you're in the kind of environment that I'm in, you have a lot of what we call shadow IT, which is you have the corporate IT that runs around doing things and tries to keep track of stuff and has change control processes and implementation methods, and then you have faculties that just kind of do things. And in the IoT space, I suspect that a lot of organizations are running into this problem where you have business units that just install stuff. So the traditional method is to have a catalog, right, where you record all the devices that are on your network and what the passwords are, and you do audits against them, and you check the firmware and you check for firmware updates and things like that. I think that that's rapidly becoming uncontrollable because the amount of IoT we're getting is actually getting out of hand in businesses. And so security teams are starting to have to pivot to finding problems rather than just relying on people doing things the right way. So you can write scripts as well to log in and check firmware versions and make sure it's updated, but it is a lot of work. It is a difficult problem. CMDB, I guess, is the short answer, but you do what you can.
You said the university that had the IoT, what do you call it?
Yeah, the fishy DOS.
It was a happy ending, but the happy ending involved passwords going in plain text across between the IoT devices.
Yeah, they got pretty.
Is that really a happy ending?
They got pretty well. I mean, they also had an outage that lasted for several days while they actually troubleshot all of this shit, all of this stuff, and so. And did all the packet captures and stuff like that. It wasn't a happy ending, really. It was facetious of me to say that it was a happy ending. They got lucky in the end, and that got them out of the problem.
So was it a configuration fail between the cameras and controller?
Sorry?
Was it a configuration failure between the cameras and the controller?
The botnet that they got on the devices just always used clear text because it has less device overhead, right? If you're running an encrypted session, it actually eats more resources. So they were just using clear text as part of the botnet.
So it was luck.
Yeah.
Yeah. Thanks.
It was coded to use plain text. They got lucky.
Do you have any more questions? No, that's it. All right, can you please thank Chris very much for that presentation?